Advent of Code, Christmas Eve. Yeah. To yield, return. Actually, you know what? Uh, okay. See. Does it output on the wire starting with C? Okay. So I actually want. Um, um, in the bits. Okay. Mm-hmm. Yeah. Yeah. Yeah, inserted. Okay. So to do that, then we just need to evaluate this. So then, yeah. Okay. Yep. Valid syntax. Oh, right. Too many Too many wires. What? Ah, that was dumb of me. Okay. Hey, I need to generate those first. Um. Oh, right. Yeah. Not the right answer. Of course it's not. Um. Values, yep. Can't type. Oh, is this reversed? This is reversed. Okay. Started 2024. Okay. That should be good. It's a little slow, but it should be good. Come on. Yeah, a little slow. Had to, but what am I looking for? Ease. Okay. Um, yes, yes, they do. Okay. Tell that there are exactly four. Okay. Wait, what are we looking for? Yeah. But how do we know we need to swap them? Oh, I see. Right, because this is supposed to add two numbers. Trying to add two binary numbers. Um, okay. I am 100% going to want this. How many gates do I have? I don't think I really want to brute force this, but at the same time, outright. I don't need you anymore. Yeah, that's a lot of brute forcing. That is a lot of brute forcing. Um, Good thing I want to visualize this. Um, and I have to hope that first graph solve via plot perfect. Yeah. Yeah. Um, so we've got that. Yeah. Okay. Okay. Yeah. Yeah. I need to give those in. Okay. Um, it is then going from left to op ID. That looks fine. I don't then need you. Plot.shell. Yeah. Uh, G is reference before assignment. What did I break? I forgot to actually make my graph, didn't I? Hmm? Oh, right. Ew. This isn't even remotely organized. Um, I thought here, minimum cut. I thought that there was a nice way to evidence stashes. Now, did I discard it? That would be annoying. So there is a way to do a draw. First, blah, blah, blah. I just want this plotted. Plotted. Um, graph layout. What am I even using? Just draw. Yeah. Oh, spring layout. That's what I'm looking for. There we go. So this is yep. Then dot draw. Okay. Shows how much I use NetworkX, and that's a mess. Okay, fine. It doesn't feel like brute forcing this is going to go well, but analyzing this is going even worse. So let me just try. I want a function hold out, which is then there probably are more efficient ways than just a straight brute force. Mm-hmm. Uh, um, just that, and get out the bits, out bits. Right. Auto instructions, no thank you. Um, Um, yes, actually. So we do that. Um, actually, nope, not D. Val. Yeah. Um, sure, sure. Yeah. So that should be correct. Then we can do this for part two. I did that backwards, didn't I? I did. That does not. Wait, flyer. Where did that happen? Oh, because that is. Oops. Perfect. Okay. So then, we have. As I could do that. I could do that. Um, no. This is going to be so terrible. So this is an 8-layer loop. Unless I look for. Yeah. Don't like that idea. I prefer analysis of this graph. Mm-hmm. Yeah. Um. Uh. Ooh, yeah, because a lot of these are going to then make cycles. So, E-wire. Yeah, yeah, yeah. So then we're going to do, yeah, absolute hack. Well, that ran quick. That ran actually amazingly quick. In thinking about it, I can do that as a sanity check that I've not introduced loops. Okay. So let's say we do this another level. How bad does it get then? Because that was really quite fast. J, K. Actually, I'll do I2 and J2. Now how long? That's still not bad. This has to bog down at some point, right? Because there's no way that this is a smart way to do it. There's just no way. Um, no, there's no way. And there's just no way, right? You can't possibly. I'm probably screwing up something else. Oh, I am screwing up something else, actually. No wonder you're finishing so quick. Let me just finish this because what I forgot to do is then um, reset things. And now my brute force is going to just completely die. Um, what? You don't get that far. Yeah, okay. Um, Yeah, because I continue. Sorry, it's not equal none. This is so terrible. Okay. Um, let's do 0. Yeah, this is exactly what I expected would happen. Yeah, because it's not even. It still is going to accelerate over time, but yeah, sounds what I thought. What I thought. It was a terrible idea. I'm gonna keep that around though. What I'm thinking might be a little better. Can I check the difference? So I guess one thing I could do. They're distinct swaps, and they're distinct swaps that do not cause loops. So what if we first about all that. Just run. How many swap? Oh, that's a lot of swaps. We have what? Um, I mean, that's a lot. Okay. Um, what's really annoying, let's go back to this again, is the plot doesn't work. At least not well. Where's my Z's? Say, wait. Am I going about this the wrong way? There might be a much. How many bits do I have? How many bits do I have? Um, why are these really 45-bit numbers? Holy cow, these are 45-bit numbers. So let's see. Going way back, how many people have finished part two? Yeah, might have a chance here still. Um, bit adder, we have A0, B0. So C0 being the output is A exclusive or B. And so actually, I can I can compute a little string for each. Yeah. C0 carry equals A and B. Then take one out. C1 equals, sorry, these should be 0, 0, 0, A1, or B1, or C1 carry. And then C2 carry is that's the annoying bit. You could be, and I don't know which way this is going to be done. Is there any nice naming here? No. Where is Z0? Because Z0, is there not a Z0? Oh, Z00. Okay. Is that? That is correct. Now this J, J, J. Okay. JFB is okay. So this is the carry bit. Right? That's the carry bit. That exclusive or that is then going to be so that's all correct. Oh, right, but I wanted to know what the okay, so the first two are correct. What I should be looking for is 0, Z02. Because this is the bit. I need to know how this is constructed. Okay, that's fine. But then what's this? Um, So this is that and that would trigger that. This is the carry bit from 0. So is the carry bit from 0. And JJJ. So if, which is the same as Z0 carry and X01 or Y01. It is correct. I mean, I can construct this graph myself. It's the intermediate naming, which is interesting. So, how about, this is a 44-bit adder, right? Yeah, so I'm going. Okay, so that is the size of the adder that I'm supposed to work with. The other thing I can do, actually. What is this example? What is that example? Supposed to find the bitwise and of... Oh, so you're completely different. Of course you're completely different. Would this be quicker for me to just do by hand? Maybe. Maybe. So what we're going to do is scrap all this, by which I mean do that. Um, yeah. Um, oh, mm, uh, yeah. Zfilog. Sorry, your return. Okay. Do this by hand time. Yeah. Okay, so this is 001. Sorry. Yeah, I want just a bit of padding on either side of those for nicer name replacements. Okay. Uh, 6. Got it. Alrighty. So this is 300. That is fine. Then this is underscore XOR. Yeah. Yep. So far, so good. And then that exclusive or that is fine. CPP, I don't know. Oh, wow. What is it? Yeah, this looks RTC. Okay, so this one's fine. RTC is CPP. They're aligning. Okay. Uh, so carry and the or that is then going to be the carry, right? Yeah. So far, so good. Um, so if we keep the same convention, this is the carry and the exclusive or. So I guess one thing actually to look for is 44, 43. Oh, crud. Um, so I missed those at the end. So a lot of these renames I actually sort of want to do automatically because they're kind of rote. Yeah. Ah, here we go. Those right next to each other are definitely wrong. Oh, and also, yeah, that's wrong. Okay. So I've spotted an error. So that's great. Yeah. Yeah. And this will be um, this will be z plus xid uh, xor. To assert false. Really? That's kind of surprising. Um, yeah, that's better. Um, yeah. And just in case something went funky, pull this out into its own. Yet that is not right. So that is part of what I need to do. PDK is that or TTM? TTM is that or this? Oh, sorry, that and this. So this is the carry, right? This is the carry. Honestly, if I keep um then I need a pad. 14, 15, how many did I do here? 13. Uh, oh, right. No longer need handled because that'll, yeah. Alrighty. Okay. Alrighty. So this should automatically be doing a lot of what I just did, which means I can add more rules. Um, okay, can do that. Date and renames. Oh, right. Okay. So the next thing to see if I can detect. Would explain that. I thought I should have had those. Okay, so we've got and so we've got so that and that. C00 and XOR PSST. Yeah, so okay. So we are looking for mm-hmm. Um, I didn't call that and. Your carry. You know what? No, we'll keep calling you that, actually. Okay. Oops. So if we got that, if we've got either of those, then this ends up being Z02 and. Or is this the... Wait, what is this? RTC is going to be... Go back to this one. Or maybe this one. Is that the carry? Is that carry? Yeah, because as soon as one of the ands is there, it is a carry. Okay. Great. I don't need you anymore. I do need you. Um, there we go. There we go. That took more than I wanted. So where do you start breaking? Here. Wait. NCJ. That doesn't sound right. Oh, wait. You're supposed to be... Carry and exclusive or. Oh, why are you... And or NCJ. Okay. So we'll get an alternate name for this. And call you 20. This is the alternate carry and. Right. Is that right? This doesn't feel right. Because the carry and up here is the normal and the and of the previous. Is this right? What are we even swapping? Mm-hmm. Mm-hmm. I guarantee I've already missed the leaderboard, which is annoying because this is computer science and architecture, and I'm actually not bad at it. Oh well. And let's do 5 there. Oh, wait, the carry and is the last and. The last and is 5 x and y. So the carry and. This doesn't feel right. Oh. Nope. I. Yeah. Because these shouldn't be in carry and XOR. Two things that are called and. That's not right. Wait, what? That is and. Though in this case, it's carry. And I do that is carry. And what I should actually do here is not call this and, but call you carry, because you are always the carry. Right. Yeah. And I think that's what was messing some things up. That's fine. That is going to be carry and. There we go. Now we're looking more sane. Yeah, Z6 came way too quick. Because Z6, we're actually supposed to get which? Where's, that's wrong. It's supposed to be exclusive OR, so Z5's wrong. This is also, is that wrong? No, that's carry in. That's okay. Z1 carry, exclusive OR, that. So, Z3, Z4. Oh, I'm not checking the alt here. Or, sorry, the op. There we go. Oop. Um, keep doing that before. Yep. Carry and, or and is carry. Wait, where was I looking? Here. Carry exclusive or this. So HDT is supposed to be swapped with. Is that Z4 carry? That doesn't sound right. Where's my exclusive ORs? I guess it's carry from source. Okay. I don't even see Z3 carry. So I see you here. Oh, that, yeah, that's correct. That's correct. So this needs to swap with Z5. Z05. Okay. Uh, That was my typo. Okay. So I just need to find 3 more of those. Check rename, pad, great. No plotting. Yeah, none of that. Uh, where was I? Yeah. There are 100% better ways to do that. Yep. Okay. So I've validated, or rather, I've found and done one of my swaps. Carry, exclusive for that. So you are supposed to be Z8. Okay. You're supposed to be. Oh, wait, no, sorry. You're supposed to be Z9. I did that wrong. This is carry and, correct? That's my convention. Come on. Carry and is. No. Okay, you're just changing up the rhythm here. Of course you are. Why wouldn't you? Why wouldn't you? This or the exclusive or would mean what? Hey, the carry and or the and normally. Oh, my brain. Okay, exclusive or SHS is supposed to be then the carry. Yeah, you're supposed to be carry. So what were you rename? Is I think Z4. Yeah, yeah, yeah. Um, yeah. Where are you even used? Oh, that's not right. Oh, yeah, because that's what I'm looking for. You are supposed to be exclusive word with. Yeah, this is wrong. Because that's supposed to be the Z15 exclusive word. So I want to find. Oh, I did those backwards. No wonder. So if I'm right, which I might not be, swap you because you are then supposed to be not that, but this. Okay. Then we break down here. And if I've not screwed up anything else up above, exclusive word this, RRC, which is and, or that, exclusive or carry. Actually, isn't that one of my rules? Maybe this is just a new incarnation. Wait, is that right? That doesn't feel right. Wait, no, carry that. Yeah, you are supposed to be Z30, aren't you? You're supposed to be Z30. Okay. Ooh. How that is not an elegant way to do that. That's an awful way to do that. How much did I miss the leaderboard by? Hour 33. Yeah, quite a lot. Um, I'm actually a little curious how some of these people did it so quickly. I know he's going to have a video. Um, oh, no, that's part one. What was my part one time? 456 versus, yeah, was a little slow. So that is disappointing, because today was my last good chance of a leaderboard. I historically, as I said yesterday, have not had great luck on Christmas Day getting points, but we will see. I do still have one more try, one more opportunity, and I will be giving it a shot. As far as this problem, we've got part one, which isn't too bad, and then part two, which is I'm not entirely sure how to do it programmatically. And I'm sure there will be discussions on the Reddit on how to do that. But let's talk about part one first. So we have this input here, which is a bunch of signal wires and a bunch of logic operations and outputs. So for part one, really all we have to do is run this on all the output wires. The output wires being the wires starting with Z, get the bits, convert that to a number, and then return that number. And actually thinking about it, I did have a minute time penalty here because I did not realize, do they actually say explicitly if this is little endian or big endian? Because here this is, that there is over there on the right. As they're just implicitly assuming 00 is over here, which makes sense. And they do say least significant bit. I missed that because I was speed reading. So I could have been, had I gotten that right, a minute faster, but that still would have been about 7 minutes, and part one leaderboard was, I still would have been a couple minutes late. So yeah, part one's really not too bad, because this is really just a graph, and that's what I implemented. Scroll up past all my awful partial attempts. So we just parse the input into the instruction graph here, or sorry, the signal graph here, the signal wires in the instruction graph, and then we can just run with a recursive function to figure out what a wire should be. And for every, I don't even need the scene set anymore because I have that. So actually, if I get rid of this, it should still give me the part one answer, and it did. So just recursively, for every given wire, if it's in signals, and we already know the value. If it's not in signals, then it must be in our instructions. So we can just get the left and the right, get the operator, do the operation, and return the value. So do that for every single wire that starts with Z. We'll get a list of bits, and we can run through that, sort them into the correct order based on their position, and actually put the least significant bit over on the right where it's supposed to be, and convert that to binary, which is very easy in Python. We've got a base 2 conversion. So that's all part one, very straightforward. Part two would have been nice to have been faster on, because I mean, as I said during the solve, I actually did this. We did binary adders back in computer architecture in college, so the concept of a binary adder is not new to me. That's why I started even sketching it out here, and was just thinking, okay, what is the quickest way for me to figure out where the errors are in this graph? I could construct the correct graph. I don't have a good idea on how to compare the correct graph with the incorrect graph. So, I mean, that's what I was starting to do here. It just build out, okay, what is the sequence for doing a binary adder? And I should probably, instead of just assuming, I should probably explain what a binary adder is. And Wikipedia is going to have great info on this as well. But let's clean this. Let's get a clean renamed instruction graph here and talk through it. So an adder is kind of built into two stages or 2 bits. We have implicitly for every single bit, we've got a carry bit coming from the previous position. This is the exact same as adding 2 base 10 numbers. And we've got the actual source bits for that number. So for the first bit that we're computing, it's very simple. We don't actually have a carry bit to deal with. So if we have either one or the other, then that bit's going to be on. If we've got both on or both off, then this needs to be off because 1 plus 1 is 2. There's a 0 in the 0th position. 0 plus 0, also 0. 0 in the 0th position. But 1 plus 0 or 0 plus 1, then this should be on. So exclusive or there. And then for the carry, we need to figure out, and I'm just going to move this up there because that actually is the next part of the adder. The carry is just, do we have 2 or more bits that are on? So again, first position, very simple. It's just a bitwise AND of those 2 bits. It gets more interesting when we're moving on to the next bit. So instead of just having Y01 and X01, we also have the carry bit here to deal with. And here I just called it AND just because this was going to come up later. But for Z01, we need to actually XOR 3 bits, these 3. And we can't do that in a single XOR. So we XOR 2 of the participants as well as the carry bit in a 3 XOR or in a double XOR chain. That'll be this bit, and that's going to apply for all the rest of the bits as well. If we come down here, we see that Z02 is the exact same. It's carry exclusive ORed with the exclusive OR of the with the X02 and Y02 bits. So that's going to be the same through the entire add sequence. Then beyond that, we need to figure out what the carry bit is going to be. And this is where it gets tricky, because now we've got 3 bits to deal with. We can't deal just with this AND. We do compute that AND, just like we did for the first bit. And if this is on, we know, okay, great. We have at least 2 bits on, we need to carry. But we could also have a case where one of these is on, in which case Z01 XOR is going to be 1, and we have a carry bit here. So if we have the carry bit and one of the 01 bits, or if we have both of the 01 bits, then we've got a carry. We mark the carry, and then carry on to the next. So really, then all of the rest here is going to be the same sort of logic, the same blocking. There are some weird things in terms of the order in which this got dumped out, but that's just how this graph got dumped. The only other thing with this kind of cleaned up and sanitized output is, as I said at the beginning, I do have this 00 AND, which is truly the carry bit. I didn't go through and do special naming for that, but all the naming gets normalized later. So yeah, that is how a half adder works, and then you just chain the half adders. They go and add the full number, and this number is 44-bit sorry, 45-bit inputs, 46-bit output. Um, so that's all well and good, but my problem was, how do we solve this? And you saw I had a few bad ideas. One was, let's plot it with network X and try and spot what the difference was, where the error was, and that would actually be good if network X plotted this well. It did not. That was just a garbage plot. And then my other knee-jerk thought was just brute force, which I didn't think would work. But then it kept terminating quickly, but that was due to errors in what I was doing in there. And then once I actually implemented it properly, it was making no progress whatsoever. So that was also just a failed experiment. And then, yeah, I had another failed experiment of, okay, hopefully most of the swaps that I can produce or that I can try are going to produce errors, are going to just make the whole thing cycle. Thinking about that, of course, it's not that the half adder actually doesn't have that many places where you can introduce a cycle by doing a swap. I was hoping that would print it down and then I could brute force it, but that also didn't pan out. And so instead, I just dumped this whole graph into a text format and analyzed it, as you saw, looking for these patterns. And where I didn't see these patterns, I fixed them. Because if we don't have this pattern, something's wrong. So yeah, this is really a hard-coded. This is me just hard-coding the answer. I am going to sanitize this before I push because I don't want to commit my answer. But yeah, most of the work was just getting this logic to automatically do the renames because renaming by hand is very tedious. And then have some extra logic for doing some swaps once I found some places that need to swap. So this is all really a hot mess, but it worked. It got me, it let me find where I need to do the swaps, and I did the swaps, and then we got the answer. So yeah, I definitely want a more elegant solution for this than just doing it all manually. But yeah, I'm sure some people on the Reddit will have some interesting ideas, and I will go and follow those ideas. But that's about all I have. Yeah, I'll be back tomorrow. One last try to get some leaderboard points, but it is not looking too hopeful this year. Gotten points every other year I've participated, even the first year when I wasn't even doing it in Python. But looks like I very well could be shut out. But I'll try again tomorrow. So that's all I got.